When the first light appears over Africa, life begins through motion and the balance of energy. Light cuts across the horizon and illuminates cracked ground and patches of gray grass. Heat increases before the sun rises. The air carries dust, the scent of dry grass, and the fading sound of wind. Across the open plain, darkness withdraws slowly. Herds of animals begin to move, forming continuous lines on the ground. The soil vibrates under thousands of footsteps. Each step represents a reaction between energy demand and survival limits. This land has no period of rest. Every organism sustains life through movement, awareness, and thermal regulation. The savannah operates as a self-balancing system, maintained through biological cycles and natural mortality. At the boundary of light, predators observe the grazing herds. They do not disrupt the structure, but help maintain ecological stability. Each chase and each pause functions as part of the natural adjustment mechanism. Light reaches the first acacia canopies. Temperature rises quickly, and dry wind sweeps across the short grass. The season determines the rhythm of life. Species that adapt continue, others disappear. This is Africa, where all living forms exist within the limits of climate and time. A continent that functions not by chance, but by biological and physical laws established over millions of years. Across the African savanna, life functions according to the laws of energy and limitation. Among the layers of dry golden grass, predators act as regulators of ecological balance. They control prey populations, remove weakened individuals, and maintain the genetic stability of the herds. No species is perfect. Only organisms that have evolved with precise adaptations can survive in harsh conditions. The first light of day reaches the grassland. A pride of lions lies scattered under acacia shade, resting after a long night of hunting. Among mammals that feed on meat, lions are the only species that live in structured groups. The organization of the pride is maintained through clear division of roles. Females conduct most of the hunting. They move close to the ground, using wind direction and terrain to minimize sound. The distance to the wildebeest herd narrows meter by meter. All signals are exchanged through posture and eye contact. No sound is wasted. Coordination is achieved through synchronized behavior rather than command. When the distance drops below 100 feet, the attack begins. Bodies weighing over 330 pounds surge forward at the same moment. The wildebeest scatter, but the pride focuses on the weakest target. A precise strike to the throat cuts off airflow. The hunt ends within seconds. Food is shared by hierarchy. The dominant male eats first, followed by females, then cubs. This order minimizes conflict and injury within the pride. A single pride can control a territory of up to 96 square miles. The area is marked with scent and sound, with roars carrying as far as 5 miles. A roar is not an act of aggression, but a biological signal defining territorial boundaries. The power of the lion lies in cohesion. No other predator on land can bring down a 1-ton buffalo without such cooperation. It is a social and biological adaptation that positions them at the top of the savannah's food chain. As the sun climbs higher, the temperature rises rapidly. Grazing animals retreat to the shade, while the leopard begins to move. It is a solitary hunter with a smaller range than lions, but a higher success rate. Its compact, muscular body and flexible limbs allow silent motion through dry grass. Its dark rosette coat is not for beauty, but for breaking up sunlight filtered through branches. The leopard hunts mostly at dawn or dusk, when light is dim and wind is stable. It stalks from the shadows, maintaining a distance of about 65 feet before charging. The final sprint lasts less than 2 seconds. Its jaws clamp onto the throat, cutting off air, and then it drags the prey up a tree to avoid scavengers. Tree climbing ability is a crucial survival advantage. Keeping the kill elevated prevents loss to lions, hyenas, or jackals. Each leopard controls a territory of 12 to 20 square miles, marked by scent and claw marks. Males and females meet only to mate. Females raise their offspring alone. In an environment where every hunt requires high energy expenditure, independence becomes an optimal strategy. The leopard represents efficiency, precise energy investment, and avoidance of unnecessary conflict. At midday, the air shimmers with heat. On an open plain, a cheetah watches a herd of Grant's gazelles from about 650 feet away. Its body is an aerodynamic design built for speed. The spine acts like a spring. The long tail maintains balance during rapid turns. Large lungs and a powerful heart supply oxygen for explosive acceleration. Each stride covers more than 20 feet. Within seconds, the cheetah reaches about 60 miles per hour, the fastest land speed of any mammal. But this burst lasts only around 20 seconds. If the prey escapes, body temperature rises quickly, forcing the cheetah to stop and cool down. Unlike lions or leopards, cheetahs lack the strength to defend their kills. Many successful hunts end with scavengers taking the prey. Speed provides opportunity, but not ownership. Every evolutionary advantage comes with an energy cost. Cheetahs require wide, open territories for visibility and acceleration. They select grasslands with clear sightlines and minimal cover. Targets are always weak, old, or separated individuals, the essence of natural selection. The process is neither cruel nor merciful. It is the biological mechanism that maintains the endurance and balance of life on the savannah. As daylight fades, hyenas begin their activity. They are primarily nocturnal animals that move constantly within territories that can cover up to 390 square miles. A clan may include more than 70 individuals, organized in a strict social hierarchy. Female hyenas are larger than males and hold dominant status. All hunting, feeding, and defense follow this order. Cooperation is essential for survival. A single hyena cannot bring down a large animal, but a coordinated group can. When they detect a target, hyenas do not hide. They use endurance-based pursuit, relying on superior stamina. They can maintain a steady speed of about 30 miles per hour for more than 3 miles until the prey collapses from exhaustion. Most hunts end not with a final strike, but with the physical decline of the prey. The jaws of a hyena generate a bite force of around 1,000 psi, strong enough to crush the leg bones of a buffalo. They digest nearly the entire carcass, including bones, skin, and tendons. No part is wasted. Their bodies convert organic matter into energy and minerals, returning nutrients to the environment. Hyenas act as the biological recycling system of the savannah, removing carcasses and preventing disease transmission. Contrary to popular belief, hyenas do not rely only on scavenging. Studies show that more than 70% of their food comes from active hunting. Within the food chain, they compete directly with lions and leopards. Their presence regulates the balance among other predators, preventing any single species from dominating. During the night, their distinctive calls can carry for miles. These sounds function as navigation and territorial signals. Each frequency conveys a specific purpose depending on distance and context. The so-called laugh is a patterned acoustic signal used for coordination, not emotion. It is a biological form of communication within the clan. When the sun fully sets, hunting activity reaches its peak. The clan splits into smaller units, maintaining contact through calls and scent. They hunt semi-independently, optimizing both energy use and territorial coverage. When one group succeeds, scent and vocal cues spread quickly to gather the clan. This system allows hyenas to maintain the highest hunting success rate among all carnivores on the savannah. Lions represent collective strength. Leopards represent stealth. Cheetahs represent the limit of speed. Hyenas represent endurance and social structure. Four species, each with a distinct survival strategy, together sustain the stability of the savanna ecosystem. None of them are redundant. Each plays a regulatory role, controlling prey populations and redistributing energy through the system. When lions decline, hoofed animals multiply, and the grasslands degrade from overgrazing. When hyenas disappear, carcasses accumulate, and bacteria and viruses spread. When cheetahs vanish, selective pressure weakens, and prey species lose adaptive fitness. Removing any link destabilizes the entire ecosystem. Nature does not operate through mercy, but through energy balance. Every predator functions as a biological control mechanism. They do not represent violence. They represent ecological limits that preserve order. Each chase is not an act of cruelty, but a survival reflex. Hunting, fleeing, and dying are essential stages of the energy cycle. Grass absorbs nutrients from decomposed bodies. Herbivores feed on grass. Predators regulate herbivore populations. It is a closed loop of life, precise and continuous. As the sunset turns red, lions retreat into the dark, leopards climb into trees. Cheetahs rest on open ground, and hyenas begin their nocturnal patrols. All four share the same space, time, and function. The savannah returns to visual stillness, yet biological processes continue beneath the silence. There is no absolute boundary between day and night, between hunter and prey. They are different phases of the same process. Predators do not bring destruction, they sustain evolution. Through this chain of interactions, the life of the savannah renews itself, each generation following the next, under the same rhythm of climate and light. At midday, when sunlight strikes directly on the ground, the savannah shimmers in rising heat. Every movement, no matter how small, becomes a signal. Herds of Thomson's gazelles, zebras, buffalo, and giraffes appear together, functioning as components of a self-regulating biological system. Thomson's gazelles move in herds of hundreds of individuals. Their ears constantly orient toward sound, and their eyes remain wide to detect even the slightest change. Their light bodies allow reaction times as fast as 1/10 of a second when a threat is detected. Each animal maintains a precise position within the group, forming a natural layer of protection for the young at the center. Their survival depends more on environmental awareness than on physical strength. A change in wind direction, a swirl of dust, or a brief shadow across the grass triggers an immediate collective response. The herd turns almost simultaneously, creating ripples of coordinated motion that sweep across the plain. No leader is required, only a reflex system encoded by evolution. Zebras occupy the intermediate layer of the grazing hierarchy. They feed on the taller grass, clearing the way for other herbivores to reach the softer shoots below. Each herd is composed of several small family groups, led by a dominant male. The black and white pattern on their bodies is not only for identification, but also for optical camouflage. Under shifting light, the alternating stripes distort a predator's perception. When dozens move in unison, the boundary between bodies disappears. Predators lose the ability to isolate a single target. This is a behavioral adaptation refined through thousands of generations. Zebras travel more than 30 miles per day in search of water. Their repeated annual routes form migration corridors, linking dry valleys with new grasslands. Their droppings and footprints loosen the soil, creating paths for seed dispersal. A newborn can stand within 15 minutes of birth, a recovery rate rare among mammals. The African buffalo is the largest grazing mammal in this region. An adult can weigh nearly 1 ton, with curved horns extending over 3 feet. They move in compact groups, reacting collectively to signals from the lead individual. When threatened, the herd does not scatter but forms a circle calves in the center, adults facing outward. This is a highly effective collective defense structure. A single charge can generate enough force to repel a lion. However, this reaction is not an act of aggression, but a mechanism to preserve population balance. By grazing on tall, dry grass, buffalo create open areas for new shoots after rainfall. Their hooves and horns loosen the soil, improving water absorption. Each season, the grasslands partially regenerate through this natural process. The buffalo serves as a link between consumption and renewal, a biological plow of the savannah. With a height approaching 20 feet, giraffes can observe across the entire plain. Their long necks allow access to acacia canopies rich in nitrogen that other species cannot reach. When one individual stops feeding and raises its head, the signal spreads across the area. They function as an early warning network for many other animals. A giraffe consumes more than 150 pounds of leaves daily, transferring energy from the canopy to the ground layer. Its droppings enrich the soil beneath trees with nitrogen and minerals. This feeding cycle creates a continuous exchange between the upper foliage and the grass below. The giraffe's heart and arteries maintain blood pressure roughly twice that of humans to ensure circulation to the brain. Specialized valves prevent reverse blood flow when lowering its head. Each defensive kick delivers nearly a ton of force enough to deter predators. However, this defense is used only during direct attacks. Most of the time, giraffes regulate grazing space and act as sentinels that signal risk across the savannah ecosystem. On the surface, these species appear to simply feed on grass. But beneath the soil, their footprints carve natural channels that guide rainwater. Each step stirs seeds and helps distribute them farther across the plain. The dung and urine of gazelles, zebras, and buffalo are rich in nitrogen and phosphate, forming the nutrient base of the soil. Insects gather around the waste, birds follow the insects, and the nutrient chain expands in all directions. No action occurs in isolation. Each herbivore functions as a link in the chain that converts solar energy into living matter. They are the main engines of the grasslands, supplying primary energy to the entire food web. When they move, the entire ecosystem moves with them. From the Serengeti to the Masai Mara, millions of wildebeest and zebras migrate along the path of moist winds. The journey spans over 930 miles, crossing rivers, dry plains, and newly sprouted grasslands. There are no maps, only inherited memory guiding the way. Each rainy season, the signals of humidity and the scent of fresh grass trigger this ancient journey. At the Mara River, thousands cross the water simultaneously, where crocodiles wait beneath the murky current. The mortality rate is high, yet the migration never stops. The loss of part of the herd becomes an energy source for other species. The carcasses drift downstream, decompose, and return nutrients to the soil. On the opposite bank, new grass is already growing, and the biological cycle begins again. If this migration were to stop, the soil would degrade, nutrients would deplete, and the entire predator network would collapse. It is one of the most essential mechanisms maintaining the stability of the savannah. Lions dominate the moment, but herbivores dominate time. They regulate the rhythm of grassland regeneration, converting sunlight through leaves into sustenance for all other life. As temperature rises and rainfall patterns shift, migration routes also change. If these movements disappear, the ecological structure will collapse. No predator can survive on land where grass no longer grows. Buffalo, gazelles, zebras, and giraffes The four primary biological forms of the plains are gears in one of Earth's oldest energy systems. Life here depends not on mercy, but on the precise function of each connection. As dusk falls, the shadows of the herds stretch across the ground. Dust, heat, and breath merge together. The savannah descends into night, yet the cycle of renewal begins again with every step. On the dry plains of Africa, life endures not by chance. Each species develops its own strategy to maintain balance between energy and limitation. There are no perfect shelters, only the most effective forms of adaptation. When sunlight strikes the ground, dry grass reflects a fractured yellow tone. Under these conditions, even the smallest difference can expose an organism. Camouflage becomes a vital defense mechanism for many species. Gazelles possess coat colors that match the soil, blending into the grassland when still. A resting individual can vanish completely within the sun-scorched terrain, rising only when wind or sound crosses its sensory threshold. Leopards use camouflage in the opposite way to ambush. Dark rosettes on their fur scatter light, allowing their outlines to merge with the alternating shade of acacia trees. From a distance of 30 feet, their body contours disappear, leaving only faint movement. Zebras use motion as camouflage. When hundreds run together, their black and white stripes create a flickering optical effect. Predators cannot distinguish individual boundaries or weaknesses within the herd. It is a visual adaptation refined through countless generations. Mara River crocodiles rely entirely on concealment. Their backs match the mud and rocks, barely breaking the water's surface. A single individual can remain still for hours, since even a small movement can end an ambush. In the grasslands, there are no mechanical warning sounds. Each species has developed its own signaling system to protect the group. Wildebeests stamp their hooves. Zebras produce a sharp whistle. Buffalo lower their heads and snort. These isolated actions, when transmitted, form collective reactions. Oxpecker birds, living alongside buffalo, serve as part of this alert network. When detecting a predator, they emit high-frequency calls that trigger changes in buffalo behavior. In return, they feed on parasites from the buffalo's skin, maintaining a stable symbiotic relationship. Some species use scent as a warning. Impala release specific pheromones when frightened. The chemical signal triggers a chain reaction that makes the entire herd run. The speed of this chemical transmission exceeds that of sound. It is a sophisticated biological warning system encoded within the evolutionary structure of each species. No species can survive long when acting alone. On the savannah, cooperation is one of the most critical survival mechanisms. Buffalo, wildebeest, and zebras often migrate together. Each species contributes distinct sensory strengths. Wildebeest detect scent. Zebras respond to movement, and buffalo react to sound. Together, they form a three-layered detection system: smell, sight, and hearing. This combination allows them to survive in high-risk regions. Lion prides also rely on cooperation. A single lion cannot bring down a large prey animal, but the pride can control entire populations of herbivores. Each member performs a specific role: blocking, flanking, or striking. This coordination is the product of behavioral selection over thousands of generations. Meerkats represent cooperation on a smaller scale. They live in colonies with complex burrow systems. Individuals take turns standing guard. When danger appears, the sentinel rises upright and produces a distinct alarm call. The group retreats underground immediately. This behavior repeats hundreds of times per day, forming an efficient model of social coordination in miniature. Beyond behavior, many species have evolved internal mechanisms to withstand heat and water loss. The oryx maintains stable body temperature even after several days without drinking. Blood flowing through its nasal passages is cooled by evaporation before reaching the brain, preventing neural damage when air temperatures exceed 113 degrees F. Giraffes possess hearts nearly twice the size expected for their body mass. High blood pressure pumps circulation to the brain at a height of about 20 feet. Specialized valves prevent reverse flow when lowering the head to drink. This is a direct result of natural selection acting on the circulatory system. Zebras sweat across their entire bodies, while gazelles cool primarily through the nose and legs. This small difference determines endurance over long distances. When the wind blows, evaporating sweat rapidly removes heat. Thermal exchange efficiency defines the biological limits of stamina. When rainfall stops, the soil cracks and water recedes from shrinking pools. A chain of reactions spreads through the ecosystem. Herbivores move north and predators follow. Some species remain, adjusting their activity patterns and rhythms. Hippos crowd into remaining pools, reaching densities far above normal. Crocodiles bury themselves in mud, reducing heart rate to 1/5 of normal and entering a temporary dormancy. Gazelles shift their feeding to nighttime when the air cools. Migratory birds leave the region, following wind currents that carry moisture from Lake Victoria. The dry season is a strict phase of natural selection. Weak, old, and poorly adapted individuals are eliminated. This process preserves the genetic strength of each population. Every loss contributes to energy rebalancing within the ecosystem. When the first rain returns, dry soil absorbs water like a sponge. Grass sprouts within 2 days, and acacia buds emerge. Migrating herds return along the same paths as before. The cycle of regeneration begins again precisely as it has for thousands of years. From behavior to physiology, from individuals to collectives, every species follows its own biological blueprint. There is no perfect strategy, only a temporary balance between energy and limitation. When the environment changes, the strategy must also change. Success belongs not to the strongest or the fastest, but to those that adapt at the right time. Across the dry ground, thousands of footprints remain. Some will be erased, others will last until the next season. This repetition forms the continuous cycle of life. The savannah favors no species, it preserves only those that adapt most efficiently. Despite heat, drought, and dust storms, this system continues to function as a vast biological organism, self-regulating, self-renewing, through every season, every cycle, every pulse of climate. On the savannah, time is measured by climate. The dry and wet seasons are not just weather patterns, they are cycles that define birth and death. Every population depends on this repetition to maintain energy balance. When the eastern winds arrive, humidity drops rapidly. Evaporation exceeds replenishment. Rivers shrink, lakes become mud pits, and fresh grass turns gray. Buffalo and antelope gather around the remaining pools. The distance between predator and prey narrows, driven by the shared need for water. This fragile equilibrium lasts until one side collapses. The soil cracks into plates like bricks. Air temperatures rise above 104 degrees AF, and heat distortion bends the image through the lens. Species intolerant of high heat retreat into burrows or shaded crevices, while migratory birds leave the region. At midday, a distant lightning strike ignites the grass. Flames spread quickly through the dry layer, creating streaks of light across the plain. In this context, fire acts as a mechanism of renewal, not simple destruction. Dry season fires begin from lightning or friction between windblown grass. Temperatures in the burn zone can exceed 1470 degrees F, removing old biomass. Seeds buried beneath the surface remain intact, waiting for rain to germinate in synchrony. Ash rich in minerals spreads with the wind. In November, southern winds bring moisture from the Indian Ocean inland. Clouds thicken, and the light shifts to a silvery gray. The first raindrops strike the ground, raising a fine mist of dust. Cracked soil absorbs water within minutes, swells, and closes. Within 48 hours, green shoots cover the surface. Gazelles return first, followed by zebras and buffalo. Lions give birth during this period of abundance. The sequence of loss, fire, rain, and recovery repeats each year across the landscape. When southern grasslands are exhausted, herds of wildebeest begin their northward migration. Zebras travel alongside them, forming columns that stretch for hundreds of miles. Above them, storks and herons follow the same corridors of wind and water. Each migration route functions as a nutrient artery of the continent. The herds disperse seeds and deposit natural fertilizer along the way. This chain of benefits extends from plants to insects, birds, and predators. At river crossings, crocodiles wait beneath the muddy surface. Lions ambush from the northern banks, and hyenas follow behind. Every crossing becomes a population-scale test of survival. Their remains provide nutrients for crocodiles, birds, and decomposers. Nothing is wasted in this cycle. Matter is redistributed across the network. Across the African continent, life operates as a continuous cycle. From the hot sands of the Sahara to the humid canopies of the Congo, all living forms follow the same principle: survival within the limits of energy and environment. Heat, water, and time are the three variables that shape every biological structure. When rain arrives, the grasslands revive. When drought returns, the desert becomes the stage of natural selection once more. No phase is an ending, only a transition between states of balance. From rivers to mountains, from predators to prey, every movement contributes to maintaining the larger system. Energy flows from sunlight to leaves, from grass to antelope, from carcass to soil. Each link, however small, remains essential to the biological network that has evolved over millions of years. Africa is not only the origin of life, it is a working model of Earth itself. Here, gain and loss, life and death, share the same purpose: to preserve equilibrium. As dusk falls over the plains and moisture rises from distant rivers, the continent continues to breathe, slow, steady, and exact. It is the rhythm of nature, without beginning or end, only continuity, infinite and true to life itself.